Hello everyone. Now we are going to talk about um, with this same kind of topic, which is finding derivatives. But of course, we are going to deal with a different kind of function right now. So far, we have studied the one of the elementary functions, which is the algebraic functions. And in this lesson, we are going to deal with the differentiation of trigonometric functions. And let's see our objectives for now. You should be able to define the derivatives of trigonometric function and of course apply the theorems of differentiation in finding the derivatives of trigonometric functions. So with this section, of course, we are going to determine first or take a look at the derivatives of functions other than the polynomials or roots of polynomials. And we will start this process of by taking a look at the derivatives of the 6 trigonometric functions. And if you want to take a look at how these formulas or rules are being derived, you may refer to our module. And since we are going to focus more to understanding and the application of the differentiation of trigonometric function, I would like you to at least remember these rules. Finding the derivatives or the 6 derivative of trigonometric function. First, we have the derivative of sine x, which is cosine x. The derivative of cosine x is negative sine x. And the derivative of tangent x is secant squared x. And for the derivative of our cotangent x is negative cosecant squared x. For the derivative of secant x is secant x tangent x. And the rule for our derivative in cosecant x is negative cosecant x cotangent x. Then I would like you, or what I can advise to you, is to at least write down this 6 trigonometric function and make sure that you familiarize yourself in these 6 trigonometric functions. It will be easier for you to differentiate those given trigonometric function. Alright, now we are going to I'll show you the illustrative example, some of the examples on finding the derivatives or how we can differentiate trigonometric function. So I have here the given y is equals to x squared sine x. And of course, since we have sine x here, we are going to apply this rule. For the derivative of sine x is equals to cosine x. And we're going to apply the product rule. We have x squared as our first term, and our second term will be sine x. And now just plugging in all the values to our rule. So we have the dy over dx is equals to the x squared times the derivative of our second term sine x plus the second term sine x times the derivative of our first term x squared. You just solve for it, get those derivatives. So then we have dy over dx is equals to x squared times the derivative of sine x is cosine x plus sine x times the derivative of x squared by the use of the power rule is 2x. And on this portion, we'll just have to simplify this. Just put this 2x on this part here. And our final answer will be dy over dx is equals to x squared cosine x plus 2x sine x. And also in finding the derivatives of the given trigonometric function, I would like you also to make yourself at least be familiar yourself to these identities, different fundamental trigonometric identities, because aside from factoring to simplify your final answer, you are going to, or you will be tasked to gaze deeper on if there is an identity on those trigonometric equations to make the given equations simpler, or to simplify it more. So we have the reciprocal identities here. For our sine x is it is equals to 1 over cosecant x. For our cosecant x, just reverse it, so we have 1 over sine x. And for our cosine x, we have 1 over secant x. And for our secant x is 1 over cosine x. And for our tangent x, we have 1 over cotangent x. And for our cotangent x, we have 1 over tangent x. And we have also the quotient identities, are sometimes called the ratio identities. And here, so we have tangent x is equals to sine x over cosine x. And for the cotangent x, we have cosine x over sine x. The most familiar identities is the Pythagorean identities. So we have sine squared x plus cosine squared x is equals to 1. And we have 1 plus tangent squared x is equals to secant squared x. And then we have 1 plus cotangent squared x is equals to cosecant squared x. And for our even odd in the identities, this is rare in when we are going to solve for the derivative of trigonometric function. But of course, I want you, to introduce this to you as well. The sine negative x is equals to negative sine x, and then cosecant negative x is equals to negative cosecant x. And for the cosecant negative x, it will be cosine x. For secant negative x, it will be secant x. And for our tangent negative x, it will be negative tangent x. And for cotangent negative x, we have negative cotangent x. And usually, or most of the time, we are going to have or use this as well, the double angle identities. We have sine 2x is equals to 2 sine x cosine x, or it may be 2 over tangent x all over 1 plus tangent squared x as well. And for our cosine 2x, we have 3 equalities for our cosine 2x in a double angle identities. We have cosine squared x minus sine squared x. And we also have 2 cosine squared x minus 1. And then we have also 1 minus 2 sine squared x, or 1 minus tangent squared x all over 1 plus tangent squared x. And for our double angle identities in tangent, we have tangent 2x is equals to 2 tangent x all over 1 minus tangent squared x. And for the double angle identities of cotangent, or the cotangent 2x is equals to cotangent squared x minus 1 all over 2 cotangent x. And let's see another example that we can apply the different identities. Find the derivatives of y is equals to cosine x over 1 minus sine x. We are going to apply the quotient rule. So first, of course, is the low times the derivative of the high, which is cosine x, minus the high cosine x, or the numerator, times the derivative of the denominator, 1 minus sine x, all over the square root of the denominator, which is the quantity 1 minus sine x. Just solve for the derivatives of those equation. Now we have 1 minus sine x, and the derivative for cosine x is negative sine x minus cosine x times the derivative of 1. Then we're going to apply here the constant multiple rule. That's why we have 0 minus our derivative for sine x is cosine x all over the squared of the denominator, 1 minus sine x. Then next we have dy over dx is equals to negative sine x plus sine squared x plus cosine squared x. We'll just have to just simply perform this. That's why we have negative sine x plus sine squared x plus cosine squared x. You will just have to distribute those to the given terms. And all over 1 minus sine x squared. And as you can see, we have here sine squared x plus cosine squared x. And we can simplify this by the use of our Pythagorean identities. Then, for that, we have, since sine squared x plus cosine squared x is equals to 1, then we have 1 minus sine x all over the quantity 1 minus sine x squared. And we can also cancel those, the 1 minus sine x in the numerator and also in the denominator. And our final answer will be 1 over 1 minus sine x. And of course, we are going to deal with the derivatives of trigonometric functions, specifically by applying the chain rule. So in this section, we'll determine the derivatives of trigonometric functions using the chain rule. And this rule deals with composite functions involving trigonometric functions. The chain rule versions of the derivatives of 6 trigonometric functions are as follows here. So we are going to let u be the differentiable function of x. For our derivative of sine, so we have sine u is equals to cosine u derivative of times the derivative of u. And for the cosine u, it is equals to the negative sine u times the derivatives of u. And for our tangent u, it is equals to secant squared u times the derivatives of u. And for the derivative for cotangent u is negative cosecant squared u times the derivative of u. And for the derivative of secant u, it is equals to secant u tangent u times the derivative of u. And lastly, for the sixth one, the derivative for cosecant u is equals to negative cosecant u cotangent u times the derivative of u. For this one, I am going to include as well this. The derivative of e raised to u is equals to e raised to u, same like the given derivatives, and then times the derivative of u. Now let's see our example. Find the derivative of find the derivative of cosine 1 over 8x. So what is our u? Our u is 1 over 8x. We're going to apply this rule. The derivative of finding cosine u is equals to negative sine u times the derivative of u. You just plug in the value of u. We have negative sine, our u is 1 over 8x times the derivative of u, which is 1 over 8x. And then we have negative sine 1 over 8x. And the derivative for 1 over 8x is 1 over 8. And then we'll just have to simplify this. Put this constant on the first part here. Here they are. And our final answer will be the derivative for cosine 1 over x is equals to negative 1 over 8 sine 1 over 8x. Now for our next example, find the derivative of sine quantity 2x cubed minus 1. So our u is 2x cubed minus 1. Since we are going to get the derivative of the sine, then apply the rule. The derivative of sine u is equals to cosine u times the derivative of u. So plugging in the value of u, we have cosine the quantity 2x cubed minus 1 times the derivative of 2x cubed minus 1. To get the derivative of 2x cubed minus 1 is 6x squared. So we have cosine 2x cubed minus 1 times 6x squared. And to further simplify, the derivative for sine quantity 2x cubed minus 1 is equals to 6x squared cosine quantity 2x cubed minus 1. Let's move forward to our third example. Find the derivative of tangent square root of 2x plus 1. So our u is the square root of 2x plus 1. Apply this rule for getting the derivative of tangent. So we have tangent u is equals to secant squared u times the derivative of u. Plugging in the value of u, which is the square root of 2x plus 1, we have secant squared square root of 2x plus 1 times the derivative of square root of 2x plus 1. Then we have secant squared square root of 2x plus 1, and then the derivative for the square root of 2x plus 1 is 1 over 2 square root of 2x plus 1 times the derivative inside the radical sign, which is 2. Then we have secant squared square root of 2x plus 1. Then just multiply 1 over 2 square root of 2x plus 1 times 2. That's why we have 2 over 2 square root of 2x plus 1. And in this portion, we can just also simplify. Or we can cancel this to here. And our final answer for getting the derivative of tangent square root of 2x plus 1 is equals to secant squared square root of 2x plus 1 all over square root of 2x plus 1. So we just get the product of these two terms. That's why we have this final answer. Now for our fourth example, we have y is equals to e raised to x tangent x. Find its derivative. And for finding the derivative of e raised to x tangent x, we are going to apply the product rule. And our first term is e raised to x, and our second term is tangent x. So we have y prime is equals to our first term e raised to x times the derivative of the second term tangent x plus tangent x times the derivative of the first term e raised to x. And so we have y prime is equals to e raised to x, and the derivative for our tangent x is secant squared x plus tangent x, and the derivative for e raised to x is e raised to x as well. So just simplify. We're going to factor out this. Then can have e raised to x times the quantity secant squared x plus tangent x. We just simplify this since we have same value here, e raised to x. Okay. And for our last example, find the derivative of f of x is equals to 2 sine x cosecant 2x. See how we are going to apply again the product rule. So we have the first term 2 sine x times the derivative of our second term, cosecant 2x, plus cosecant 2x times the derivative of our first term, 2 sine x. Then just get the derivative of those functions. So we have 2 sine x times the quantity negative 2 cosecant 2x cotangent 2x. Why there is negative 2 here? Because we get also the derivative of this 2x. And then plus cosecant 2x times the derivative of 2 sine x is 2 cosecant x. Now just distribute those. 2 sine x times the quantity negative 2 cosecant 2x cotangent 2x is negative 4 sine x cosecant 2x cotangent 2x, plus the product of cosecant 2x times 2 cosecant x, cosine x is equals to 2 cosecant 2x cosine x. And then it's just been on this one. I would like you to gaze deeper because you are going to see different identities here in this part. First one is the reciprocal identities. For the cosecant 2x, or on our table or on our rule, we have cosecant 2 theta is equals to 1 over sine 2 theta. That's why we have here. And then for the cotangent 2x, we're just going to use the ratio or quotient identities. So we have cosine 2x over sine 2x. That's why we have negative 4 sine x times 1 over sine 2x times cosine 2x over sine 2x plus 2 times 1 over sine 2x times cosine x. And let's just continue the process. Okay, so we'll just have to perform the given, and then what I mean to say is distribute. So that's why distribute those negative 4 sine x times 1 over sine 2x times the quantity cosine 2x over sine 2x. And of course, we are going to get the to solve for the sum of it. That's why we're going to get the common denominator, which is the sine squared 2x. And we also get the product of 2 times 1 over sine 2x times cosine x. And we'll just have to get or solve for the sum of those two different terms. That's why we have negative 4 sine x cosine 2x plus 2 cosine x sine 2x all over sine squared 2x. And as you can see, we have also the double angle identities here. Okay, so for the next step, we have negative 4 sine x and cosine 2x is equals to the quantity cosine squared x minus sine squared x plus 2 cosine x. And for the double angle of sine 2x is quantity 2 sine x cosine x. And for the double angle of this sine squared 2x, we have 2 sine x cosine x squared. And we can cancel these two different identities. And then what else that we have left here? We have 4 sine cubed x, this part, all over 4 sine squared x cosine squared x. So where this came from, we just solved for this. The quantity 2 sine x cosine x squared. And then we can cancel this. And we only have sine x over cosine squared x. We can just we can set this apart, the cosine squared x. It will look like as sine x over cosine x times cosine x. And by applying the ratio or quotient identities here on sine x over cosine x, and also the reciprocal identities here in 1 over cosine x, we can get the final answer for the derivative of the given f of x is equals to 2 sine x cosecant 2x is equals to secant x tangent x. So that will be all, and thank you so much. Good day.